vlog! Welcome to my vlog! Hi vlog! Kami na pala yung Chicharon Walkers!
Yes!
Kasi alam ko lang. Kami nga pala ang Chicharon Walkers. Ito si Ashley Gil Padua.
Good day everyone! Today I will demonstrate a real-life application of Boyle's Law using a simple long model made from plastic bottle and balloons. But first, what is Boyle's Law? Boyle's Law states that pressure is inversely proportional to volume at constant temperature. This means that when the volume increases, the pressure will decrease, and when the volume decreases, the pressure will increase. This is exactly how our lungs work when we breathe. The materials I use are one plastic bottle, two balloons, tape or rubber band, and scissors. First, I cut off the bottom part of the plastic bottle. Next, I put one balloon inside the bottle and stretch its opening over the mouth of the bottle. This balloon represents the lung. Then, I stretch the second balloon over the open bottom part of the bottle. This balloon represents the diaphragm, which is the muscle that helps us breathe. I made sure everything was sealed tightly so that no air could escape. Now, I will demonstrate how it works. When I pull the bottom balloon downward, the balloon inside inflates. When I push the bottom balloon upward, the balloon inside deflates. When I pull the bottom balloon down, the space inside the bottle increases. This increases the volume. According to Boyle's law, when volume increases, pressure decreases. Because the pressure inside becomes lower than the pressure outside, air moves into the balloon, causing it to inflate. This represents inhalation. When I push the bottom balloon upward, the space inside becomes smaller. The volume also decreases. According to Boyle's law, when volume decreases, pressure increases. The higher pressure inside pushes the air out of the balloon, causing it to deflate. This represents exhalation. This shows that breathing is a real-life application of Boyle's law. In conclusion, this simple long model demonstrates how Boyle's law explains the process of breathing. The changes in volume inside the lungs cause changes in pressure, allowing the air to move in and out naturally. And that's all. Thank you for watching.
Hi, I'm Ashley Padua, and today I'm going to show you an experiments of gas law. These are the materials I use. Now let's start by placing the lit candle on the plate. When the candle is covered by a glass, the air inside heats up, making the gas particles move faster and increasing the pressure since the volume remains constant. This follows Gay-Lussac's law. When the flame goes out, the air cools, the pressure decreases, and water rises into the glass because the pressure inside becomes lower than the outside pressure.
Hello, my name is Chicharon Garcia and I am here to demonstrate Charles' law using a can, lighter, and a cold water. But first, what is Charles' law? Charles' law states that the volume of a fixed mass of an ideal gas is directly proportional to its absolute temperature when pressure remains constant. As the pressure increases, gas particles move faster and spread out, causing the volume to increase. I'm gonna put a little water in the can. Just a little bit. Now I'm gonna use a tongue to help me hold the can. Strictly don't try this at home as this is just an experiment. Trigger warning, usage of fire. it's ready. Yes! It worked perfectly, as you can see. So what happened? When I dunked the can into the bowl, the steam condensed rapidly. This rapid condensation of steam created a significant drop in pressure inside the can. This is an application of the gas law. When we lower the temperature inside the can, we're also lowering its pressure. So inside this can is at lower pressure than the surrounding area, which caused to implode inside.
Gas laws can be applied in a car engine because a car engine works by controlling and changing the pressure, temperature, and volume of gas inside the cylinders.
Good day, everyone. Today I will demonstrate how making popcorn shows Gay-Lussac's law. Gay-Lussac's law states that when the temperature increases, pressure also increases, as long as the volume remains constant. Now, let me show you how this works through making popcorn. Inside each popcorn kernel, there is a small amount of water. When we heat the kernel, the water turns into steam. As we all know, steam is gas. The hard outer shell of the kernel keeps the volume constant. Because the gas cannot expand, the pressure inside continues to increase as the temperature rises. Eventually, the pressure becomes too high for the shell of the kernel to handle. So that is when the kernel explodes, and it pops into what we know as popcorn. So in short, as temperature increases, pressure increases inside the kernel. When the pressure becomes too great, it bursts. That popping sound we hear is a real-life example of Gay-Lussac's law in action. And that is all for today's science lesson and experiment. Thank you.
Yeah. Okay, love you guys. Don't forget to smile.